All right. Anything else to share? I don't think so. I think we're just fine in terms of that. So, couple of things due. So if you recall from last class, we did what I call non-ranked voting, which we saw two different types of non-ranked voting. The plurality voting, where each voter gets one vote and they vote for a single candidate, and then the candidate with the most votes wins. So obviously that's easy to do. When we think of voting, we often think of plurality voting because that's what happens so often in the American system. Like when we vote for our Senate candidate or our congressional candidate, both at the state and local levels, it is plurality voting. Most votes, everybody gets a vote, most votes wins. And then we also saw the idea of approval voting, where I as a voter can approve any candidate that I like, and implicitly you're disapproving of any candidate that you don't like, that you don't vote for. So I could vote for 3 or 4 candidates and they'd all get a vote. And that eliminates this need for 2 candidates with similar positions to have one drop out. Because if I like both candidate A and B, I could vote for both of them, right? Now, one thing that people don't like on approval voting is that if I am approving for a specific candidate, if I approve of a specific candidate and I approve of a different candidate, so I approve of 2 candidates, I may like one more than the other. And with approval voting, there's no distinguishing that I like the candidate A better than candidate B. All right. And so that's what we're kind of going to go into today. What we get into now is what's called the ranking methods of voting. So these are still methods of voting, but using a ranking of who I like the most to who I like the least. All right. So this is where we get to distinguished choices. And show everyone how we distinguish choices. Now, there's a number of ways to do this. But what we will do is we will use a numerical system called the board account. That just means I give everybody from 0 up to n-1 for each candidate. N-1 means the number of candidates minus 1. So if I have 5 candidates, I'll list 0, 1, 2, 3, 4. All right. There are other numerical systems where maybe I like 2 candidates equal and I can tie them. And maybe I really dislike one candidate and I can put that one at the very end. But those aren't what we're going to use. We're going to use the idea of the board account. All right. So every candidate is going to get a number from 0 up to 1 minus the number of candidates. And 0 will be the worst number you can get. That's the most disliked. And if there's 5 candidates, 4 is the highest number you can get. Does that make sense? So 0 is the least liked, and the higher numbers are the most liked. Okay. Now, obviously, the advantage of ranking is that I, as a voter, can distinguish between candidates. All right. It turns out, after you give these rankings, there's a number of different methods you can use to determine who wins. So let's say we have a bunch of voters and they all rank their top candidates. Well, the first method of who wins that we're going to look at is called the counting points method. So every voter ranks the candidates, and then counting points is exactly what it sounds like. We're going to count up the number of points. Remember, the higher numbers were the most liked, the zeros were the least liked. So the highest number in total wins. That's the counting points method. Pretty straightforward. We're just going to total up the points and highest number wins. Okay. So let's take a look at this example here. We have 4 candidates running for whatever position they're running for. We have A, B, C, and D. And if I'm using the counting points method, I simply add up all of these numbers for A. So notice 1 plus 0 plus 1 plus 3 plus 3 plus 3 plus 0. So add up all of those, and you should get an 11. So A in total has 11 points. B in total, 2 plus 2 plus 2 plus 1 plus 2 plus 1 plus 2. B actually has 12 points. If you look at candidate C, C has 3 plus 3 plus 2 plus 3. C would have also 11 points. And then D has 0 plus 1 plus 3 plus 2 plus 1 plus 0 plus 1. Yeah, I think D has 8 points. All right. So I simply counted up the points, added them up. Since we're using the counting points method, B wins. All right. Pretty straightforward. Has the most points, that person, that individual wins. Now, the interesting thing about this this example think about what would have happened in plurality. Only the very top votes would have counted. I want to show you now a top vote is the number 3 here. So you'll notice that candidate A got 3 top votes. Notice that candidate B got 0 top votes. Candidate C got 3 top votes, and candidate D got 1 top vote. You guys understand what I mean by top votes? They got the number 3. Somebody liked them the best. So if people would have stayed true, in plurality, B might not have gotten any votes, right? B might not get any votes in a plurality vote, but they win using the counting points method. So that's a really interesting thing. Using different methods, we can see here, is going to lead to different results. Now, maybe B would have gotten a lot of approval methods. We don't know that. We don't know what level approves and what level disapproves. But per voter. So we don't know approval on that one, but that's how it goes. All right. So counting points has some nice features. It's pretty logical. It's pretty straightforward. Obviously, if each voter gets to vote, and there's lots and lots of voters, you'll want a computer to be able to count those up. But you can do that. It's easy for a computer to count up points. That's what they're good at. And it has the advantage that I, as a voter, can get to distinguish, right, between my favorite candidates. But even with the ranking methods, we still have disadvantages. And these are similar disadvantages, or in fact, the exact same disadvantages that we had in other systems. When you have multiple candidates, the candidate that wins may not win head-to-head against everybody else. Remember that word is called condorcet? So your candidate might not be condorcet, might not win against everybody else head-to-head. And it turns out, even with the ranking and counting points, if you were to, as a voter, rearrange your numbers, you take away points from a loser, the outcome could have changed. So what I mean by that is maybe I was voter number 3. If I take this best place away from D and give it to A, it's going to change the outcome. Does that make sense? So If voters read or if they adjust their ranking, then the outcomes could change. All right. All right, so counting points is probably the most straightforward way of dealing with ranking, but there are other methods using ranking methods as well. Other methods determine. One of those is what we call sequential pairwise voting. So with sequential pairwise voting, we're going to start with an agenda. An agenda is just a list of our candidates in some order. The first two are going to compete in a head-to-head battle. Now, when we do a head-to-head battle, all we care about is who's more preferred and who's least preferred. All right. Winner moves on and challenges the next person in the sequence. And the loser is out. And you just keep doing this over and over and over until you get one candidate remaining that wins. So we're going to start with an agenda, some list of candidates, like I'll just do this alphabetically right now, A, B, C, D. These two are going to battle. The winner from those two is going to go against C. And then those two battle. The winner from those two is going to go against D. Does that make sense? Now, this is the way we're going to do it in this class, but there's obviously different ways to do this as well. You could arrange this in a quote like bracket style or tournament style. So think of like the NCAA basketball brackets, where whoever wins between A and B goes on and faces whoever wins between C and D. And then whoever wins in that is the actual winner of the whole thing. So you could do this in bracket style as well. And a lot of competitions are done that way. Okay. We're not going to do it in bracket style. We're going to do it in the sequential pairwise. We're going to do it in order. But the same thing could happen. All right. And just like sports, sometimes A matches up really good against B, but not so good against C, right? So the way the bracket is arranged can make a big difference, all right? Not always, but sometimes the way the bracket's arranged can make a big difference, all right? So let's do an example or two to go through this. So we'll let our sequence be alphabetical, A, B, C, D. And let's therefore look at A versus B. Now, when you go A versus B, you just care about who liked what candidate. All right. So voter 1, who do they prefer between A and B? Well, pretty obvious, they prefer B, right? They gave them the higher number. Voter 1 gave B the higher number. Voter 2 also gave B the higher number. Now, does it make any difference whether it's 2 higher versus 1 higher? No, not sequential pairwise. Voter 3 also gave B the higher number. Voter 4, voter 5, and voter 6 gave A the higher number. And then voter 7 gave B the higher number. Everybody see that? So that means in a head-to-head battle, A would have gotten 3 votes, specifically from voters 4, 5, and 6. B would have gotten 4 votes, specifically from 1, 2, 3, and 7. So B wins. Now that's just the head-to-head battle against A and B. Now B is going to move on and face C. And I'm going to do the exact same thing. A lot of times I won't write which voters. I'll just write how many votes they would have gotten. So let's look at B versus C. Voter 1 would prefer C. Voter 2 would prefer C. Voters 3, 4, and 5 would have preferred B. Voter 6 prefers C. Voter 7 prefers C. So C in a head-to-head battle would have gotten 4 votes, and B would have gotten 3 votes in a head-to-head battle. Everybody see where I'm getting at? So B got 3, C got 4, C wins. So A and B, some people will write it like this: A, B, B wins, B, C, C wins. They'll kind of ladder it. You guys know what I'm saying? Some people will write it that way. I guess I can do that too. Let me write that over here. A versus B. Who comes out of that? Well, in this case, B did. B versus C. Who comes out of that? Well, in this case, C did. C versus D. We write that down here. C versus D. We'll see who comes out of this in a head-to-head battle by, again, looking at C and D, who would have gotten which votes. This one's pretty easy, lots of zeros. C would have gotten voter 1, would have gotten voter 2. C would have gotten voter 3, D would have gotten voter 4, D would have gotten voter 5, voter 6 would have gotten a C, voter 7 would have gotten a C. So in this case, C, once it got 4 votes. D got 3 votes in a head-to-head battle. So in a C versus D, C wins, and therefore C is the ultimate winner with this sequence. So C wins the whole whatever they were going for. The position, if we're talking about political position, if we're talking about some game, C wins the whole game. I don't know what they were candidates for. Now, I want you to try one more on your own. I'm going to take the exact same table, and I want you to do CBAD. I want you to try on your own to do the sequential pairwise with schedule C, B, A, D. If you get really good at these things, it starts getting pretty quick because you start counting quicker, right? And all that kind of stuff. Let me go through this. So let's look at C versus B. Those are my first 2 pairs, C versus B. If you look at this, voter 1 goes to C, voter 2 goes to C, voter 3 goes to B, voter 4 goes to B, voter 5 goes to B, voter 6 and 7 both go to C. So that means C gets 4 votes. and B gets 3 votes. So in a 4-3 score, C wins. And so C is going to win and move on. And then we say, well, now it's C versus A. Because A is the next in the sequence. In C versus A, first voter is going to vote for C. They have C ranked higher. Second voter is going to rank C higher. Voters 3 and 4 and 5 all rank A higher. Voter 6 ranks A higher. And voter 7 ranks C higher. So in C versus A, C gets 3 votes versus A, who gets 4 votes. Since A has more votes, A wins and moves on. Since A moves on, they're going to go and face D in the final head-to-head matchup. A versus D. Voter 1 goes for A, voter 2 goes for D, voter 3 goes for D, voter 4 goes for A, voter 5 goes for A, voter 6 goes for A, voter 7 goes for D. So once again, A got 4 votes. And D got 3 votes, so A wins. So C versus B, C came out the winner. Then faced A, C versus A came out the winner. A versus D, A wins the total, right? So in sequential pairwise voting with this list, A wins everything. And this example highlights one of the main issues that you have additionally with sequential pairwise. If you have 2 different agendas, you can end up with 2 different winners. We saw in our last example with the ABCD, C ended up being the winner, where CBAB, A ended up being the winner. Okay. So who wins is in some ways determined by the agenda, right? And that's the main additional disadvantage of sequential pairwise. Now, the basics of re-ranking losers, right? Redistributing points from losers to other losers can change the outcome. That still holds true as well. Oftentimes, this is not Condorcet as well. in this case, B can beat C. I'm sorry. C can beat B. B can beat A, but A can beat C, right? There's kind of a three-way who can beat who there. So it's not Condorcet. And I didn't put all these other things down, but you can always take away votes from a loser and give those votes to another loser. It might change the outcome. All right. But the additional disadvantage of sequential pairwise voting is that sometimes it depends on the agenda who wins and who loses. And we've probably all seen that in bracket systems too. You know, this team might match up really good with this other team, but really bad against a different team. So team A might match up really good against team C, but team A matches up poorly against team B, kind of thing. So, okay. So we've seen two systems. First, the counting points method of ranking and determining a winner. Second was the sequential pairwise. And we're going to look at one more system called the Hare system. H-A-R-E, like tortoise and the hare. Okay. This is the system in which you continually delete the least preferred candidate. In other words, instead of trying to pick the best candidate, let's try to get rid of the worst candidate. And we continually get rid of the worst candidate until we have one candidate left. Now, if there's kind of a tie for last, we'll get rid of both of those. And if at the very end, there's a tie for, least, then we'll have to determine it based on something else. Probably like who got the most first place votes to begin with, or something like that. So if there's a tie at the very, very end, we'll give it to whoever got the most place votes to begin with. Now the Heritage system does take a little bit longer to do because it's going to require us to have multiple tables set up. So let's take a look at a fairly small system. Here's a system with 5 voters and 4 candidates. Let me open this up. We're going to use counting points to determine the least preferred, okay? Counting points is going to get least preferred. So maybe I'll add another column there. I think I can do that. Right. All right. So let me write the total in that column there. So candidate A originally, right now, has, looks like 10 points. Candidate B, right now, it looks like has 11 points. Candidate C right now only has 2 points. And candidate D right now has Looks like 7 points. Okay. So what we do is we say the least preferred is candidate C. So eliminate that person. So this candidate gets eliminated. Just draw a line through that candidate. Now here's where it starts becoming interesting. If I've eliminated C, then I should eliminate all of their points as well. So I create another table with 3 candidates, and I am going to have to re-rank them according to the new board account, because the new board account will go 0, 1, 2. I am going to re-rank candidate A, D, and B according to that new board account. Does that make sense? So in this case, candidate A is still going to get a 0. Candidate B, well, let me do this. Candidate, the least preferred for voter 1 is still A. The next preferred is D, and the next preferred is B. So B actually should have a rank of 2 if our numbers were 0, 1, and 2 on our board account. Does that make sense? Voter 2 now, after C has been eliminated, the least preferred candidate is D. So I'm gonna give D a 0. The next least preferred is A. So I'm gonna give A a 1. And the next least preferred is B. So I'm gonna give B a 2. And I'm going to do that for each voter. Voter 3, the least preferred is B. The next least preferred is A. The next least preferred is D. So I'm giving the new board account each time. Sometimes I don't have to change a lot. Sometimes I have to change every number. Least preferred gets a 0. Second least preferred gets a 1. Most preferred gets a 2. Does that work? And then I can add things up. 1, 2, 3, 4, 5, 6. Looks like 6 points for A in this new system with 3 candidates left. 6 points for B in this new system with 3 candidates left. And 3 points for D in this new system. So D now has the least points. So we're going to eliminate D. Draw a line through D. When I say a line, just eliminate that. I'll copy. Uh-oh. And move on. So D is now gone. And I'm just left with the 2 candidates, A and B. Now, because A and B, there's only 2 candidates, the new board account should be 0, 1. So notice A already is the least preferred. B gets a 1. For voter 2, A is less preferred, B is more preferred. For voter 3, B is less preferred, A is more preferred. For voter 4, B is less preferred, A is more preferred. For voter 5, B less liked, A more liked. So now at the end, we can see that B is our least liked. So we eliminate B, and there's only one candidate that remains, therefore A wins. Does that make sense? So we continually eliminate the least preferred and then re-rank based on the new board account. By the way, notice that A did not have the most points to begin with. A did not have, if we were doing counting points method, B would have won. Because they had the most points. But the Hare method is this continual elimination of the least preferred candidate. And in this case, if we just keep eliminating candidates, A wins. That makes sense? So that's the Hare method. Again, H-A-R-E. I don't know if that's named after the last name of a person or if that's named because of like the tortoise and the hare. Like the candidate that keeps going eventually wins. Right? I don't know. By the way, those tables are on your notes without the totals. So if you printed out the notes, you have those. Okay. Now, one of the nice things about the Hare method is that because you eliminate the least preferred candidates, oftentimes the most off-putting candidates get thrown out. All right. And just like any other ranking method, it's harder to game the system. You can, but it's harder to play games with the Hare method system. So because a lot of the really off-putting candidates get thrown out, voters tend to be more satisfied with the Hare system. All right. If you looked at the percentage of voters who are satisfied, the Hare system would give you a high percentage. Right? And it's because it throws out those really least liked candidates. And sometimes candidates who win plurality stick out. So sometimes if you have lots and lots of candidates vying for a position, the ones that really stick out are the ones that get a lot of plurality votes. But they're also sometimes the least liked because they stick out. So again, Hare system eliminates those off-putting candidates quickly. All right. But just like every other system that we've seen, not always Condorcet. And if you take away points from a loser and put it on another loser, sometimes that can change the outcome. All right. So those two disadvantages just happen over and over and over again with multiple candidates, right? That not every system guarantees Condorcet, and there's no system where you take away points from a loser, give them to a different person who lost, that new person could now win. Right? Which I hope kind of shows you that there's really no perfect system here. Right? There's no perfect system. So if you're envisioning utopia in a voting system, it's just not going to happen. So on your homework, on your test, you'll have to do different voting on various systems. All right. So let's go through each of the various systems and see who wins. Now, what I've done, this is a different ranking than, this is a different system, excuse me, than we saw in the previous examples. But what I'm going to do is I'm going to go through every voting system that we've looked at based on this ranking. All right, based on this table. Now, if we see a ranking system like this and you're asked to do plurality, we're just going to assume that the top vote getter would have gotten the vote in plurality. Does that make sense? So for instance, we're going to assume voter 1 would have voted for D in a plurality system. Okay with that? So all we need to do is look at the top votes. So A got 1, 2, 3 top votes. B would have gotten 1 top vote. Voter 5 would have voted for B. Voters 6 and 7 would have voted for C if they only got 1 vote. And voter 1 would have voted for D. So out of the 7 individuals, A got the most top votes. And so in a plurality method, A wins. Okay. Pretty straightforward. So if I ask you for plurality and I give you a ranking, just assume that the top vote was their plurality choice. Now, if we do an approval, What's the problem with approval in this case? Well, with the approval method, oh, I thought I had my approval. Dang it. I'm going to have to tell you, well, voter 1 approved for these candidates, and voter 2 approved for these candidates. So if you see an approval method, I thought I had this on the next slide, but apparently I don't. If you see an approval method, what will happen is this. You'll see little A's for which candidates each approves of. Okay? And some voters might approve their top 3 choices. Some voters might only approve their top choice. Some voters might approve for 2 candidates. Some voters might approve for 3. Some voters might approve for, 2. Assume. Some voters might only approve for 1. See that? So if I give you an approval method, I'll give you something like this. I'll give you A's, which lists out all the approvals. Now, once that's done, it's just a matter of counting how many approvals each candidate got. Everybody follow that? So with the approval, how many approvals did A get? A got 4 approvals, it looks like. B ended up with 6 approvals. C ended up with 3 approvals. And D ended up with 3 approvals as well. So in that case, if we're doing the approval method, B wins. Does that make sense? Counting points. Straightforward, we're just going to look at points. How many did A get? How many points did B get? So on and so forth. A, it looks like got 10 points. B, it looks like looks like 13 points, if I'm counting that correctly. B got 13 points. Count how many points C got. Looks like 12 points. And D only ended up with 7 points. So with the counting points method, B also wins. Does that make sense? Plurality, approval, counting points. So plurality, we just count the top votes. Approvals, we count all the A's. And again, if I give you one, you'll have little A's next to it. And then for counting points, we just count up the number of points. Those are the 3 ones where you just essentially just count different things, but counting. All right, let's go for sequential pairwise. And this says use the agenda CA DB. So C versus A. Let's do that. C versus A. C gets voter 1. A gets voter 2. A gets voter 3. A gets voter 4. A gets voter 5. C gets voter 6 and 7. So that's a 4-3 win by A. Right? So CADB. A gets 4 votes. C gets 3. A wins and moves on. So now A is going to take on D. So A is in apple versus D is in dog. Notice D gets voter number 1. A gets voter number 2. A gets voter number 3. A gets voter number 4. D gets voter number 5. Voters 6 and 7 also go with D. So while D scored a lot less points than A, D versus A head to head, D actually wins. Again, in a 4-3. And then D moves on to take on B. So D is in dog versus B is in boy. B is going to get voter 2, voter 3, voter 4, and voter 5. D is going to get voter 1, voter. No, B got more than that too, didn't they? So B also got 6 and 7, right? That's kind of a blowout. B outranked D in every voter except for number 1. But 6-1 in that case. So 4-3, A wins. 4-3, D wins. This is 6-1, B wins. And so B wins sequential pairwise as well. All right. I don't know if you like this method, just putting the vote count totals right underneath the letters and then moving the winner on. sometimes like that. By the way, in a different sequence, other candidates may have won, right? Using a different sequence. Let's use our last method, which is the Hare method. Which is always eliminating the least liked person. Now, we already counted points here. We did that a couple of, well, here, right, in 1C. And we saw, hopefully we saw, or we remember. We go to here. Move this thing around. So if you remember, the first point count system gave us 10, 13, 12, and 7. So we, in our first step, should have eliminated D. All right. Once you've eliminated D, get rid of them, get rid of whoever D was. I need to go to the board account of 0, 1, 2. And so 0, 1, 2, that's already set up for voter 1 because that was least liked. Now I have 1, 2, 3. So I got to go least liked, next, favorite, least liked, next, favorite, least liked, next, favorite. 0 already is least liked, next, favorite. Voter 6, that's least liked, next, favorite. Voter 7, least liked, next, favorite. Now count the points here. It looks like A has 7. Looks like 1, 2, 3. Looks like B has 7. And it looks like C has 7. All right. Now we're in kind of a predicament, right? We have a 3-way tie for first. And what did we say earlier? Well, if there's a tie at the end, we could eliminate 2 candidates at once. Okay. Or we can eliminate 3 candidates. So if there was like another candidate in here that got, you know, let's just, for instance, if C would have gotten 9, we would have said, well, let's eliminate A and B at the same time and C wins. Okay. But we don't have that. We have a 3-way tie for first. And if you ever have a tie for first, you have to break it using some other method. Generally what we do is we go back and say, out of these 3, who got the most first place votes? And when I say first place votes, I mean to begin with. And if you look at first place votes, A got 3, B got 1, C got 2, D got 1. All right. And so between A, B, and C, D is kind of out of the picture because they already got eliminated. So even if D would have gotten 4 first place votes, or let's say D got 5 first place votes, they still wouldn't count. Does that make sense? You still are only picking from the 3 remaining candidates. So A got the most first place votes. So we'll say A, since there's a 3-way tie for first, A wins. Everybody okay with that? So in step 1, we eliminated D. In step 2, we had a 3-way tie. And then we broke the tie with first place votes. Okay. And we ended up figuring out that with the first place votes, A wins. Now, I want you to think about this. If you are candidate A, what system do you want counting your votes? Well, you want either the plurality system or the Hare method. If you're candidate B, you want the approval system or the counting points method or this sequential pairwise. It turns out candidate C wins with some other sequential pairwise. And you can also make candidate C win if you get different approvals. Okay. D doesn't win in any of these. And it's kind of, you can, in fact, make D win in a sequential pairwise too. All right. So you can get basically any candidate that you want to win using the right system in this example. All right. You just have to pick out the right sequence. But what this shows you is that different methods are giving you different results. All right. Now, obviously, there are some systems where, you get a candidate that everybody likes. And that candidate wins no matter what you throw at it, which voting system you choose. So there are some systems, but there are lots and lots of systems where different methods give you different results. For who wins. If you want a perfect system, then you want it so that the candidate with the most first place votes always wins. You want it where the candidate who's condorse it always wins. You want it so that if A is the winner and A stays ahead of B on every ballot, then A still wins. You want it so that if a non-winner drops out, then the winner stays the same. But as we have seen in the past examples, there's no system like that when you have lots of candidates. When you have lots of candidates, there is no perfect system. You can't devise a really, really good system which always satisfies those things. Right? And so some people throw their hands in the air and say, well, why use any system at all then? What's the big deal? Well, we obviously have to be able to, especially in a democratic republic like the United States, we have to have some way of choosing things. And so we have to kind of pick the system that we like, the system that maybe has some advantages. Like in a hair system, we said the off-putting candidates usually get thrown out. The approval system, you don't have to always have two individuals who are really close. You don't always have to have one of those individuals get out of the race. Right? And whatever system you pick, make sure that everybody is like, if you are devising a system, we need to make sure that the way in which we pick our candidates is known well ahead of time, well before the vote takes place. If you do a vote and then the system, you say, I'll change the system, then fairness gets thrown out the window. Okay. And if you're deciding this, you probably want to go with a fairly known method. And as we saw in our last example, we better have a clear way to break ties if that ever happens. So with the plurality method, there can be ties. With the approval method or the counting points method, there could be ties. So we need to figure out how to break ties if that happens. And then we need to make sure that everybody's in agreement. So everybody writes it down and signs off on it. So if you're in a large organization and you're devising a system, make sure, in order to have a fair system, you want to have those things. You want to make sure you have the system set in place. Everybody knows the game, so to speak, before the vote takes place. You want to go with a known method so that everybody can understand it. You want to make sure that there's ways to break ties if there is a tie, and write it down. Make sure everybody's in agreement with that. Is that all right? So there is no perfect system, and that's what we'll do. All right, I will stop there. I just realized we're out of time. It's a little bit long today. So I'll stop there. And then remember, no class on Thursday due to Professional Development Day. All right.